Hello, 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 and welcome back to Shiksha DaCosta. Today we're going to learn about all the different ways where we can apply acute triangle trigonometry to real life, especially looking at our careers. So today, by the end of this, you should be able to solve problems that require the use of sine law or cosine law in acute triangles, especially ones that come up from the real world. So start thinking about this in the right way. My friend Annie wants to measure the width of a river, but a river is very hard to measure, especially when you cannot get to the other side to stand on it because there's a giant cliff in your way. How could she still measure the width of this river? Pause the video here and think about that for a minute. Well, in this case, because she has a protractor, one of the things she can actually do, and this is a neat trick, you can find a landmark. So in this case, she's found this little crack right here in the cliff, and she's gonna stand across the cliff face, across the river from that crack, and she's gonna put a protractor right there. And if you look straight down the protractor over here and make sure that it's 90 degrees, you can see that you are exactly across from it. Then, if she can stand over here and do the same thing, put the protractor in a way that the 0 degrees is pointing along the length of the river, so it's flush with the river, and then look down at that same feature, in this case, the crack, she might see that, hey, that is about a 40-degree angle. And she might say to herself, I went from here to here, and that was 50 feet. But by doing this, she's created a right angle triangle. And because she knows this length and she knows one angle, well, plus the right angle itself, she knows that, well, this is the adjacent side, this is the opposite side, and this is the hypotenuse when we're talking about this 40-degree angle here. And so if I'm trying to find out the width of the river, that's the opposite. I know that the adjacent side is 50 feet. So opposite and over adjacent involves the ratio tan, especially because this is the angle that we know. So tan of angle 40 is equal to the width of the river divided by the adjacent side, which is 50 feet. And if I want to isolate W, I just multiply both sides by 50. And that tells me that the width of the river, or that the river is about 42.5 feet wide. So you can actually use trigonometry to measure distances that you can't physically reach yourself. And people like surveyors and cartographers use them to find such distances like the widths of rivers or roads or canyons. Carpenters could also use trigonometry. They could measure distances for furniture or for even buildings that they're creating. In this example, a DJ is playing in between two spotlights that are mounted 5 meters apart on a track on the ceiling. He estimates that, okay, if this is 5 meters apart, then the red one is at an angle of 50 degrees, and the blue spotlight is at an angle of elevation of 60 degrees. And of course, just like I did over here, because the ceiling is parallel to the floor, that means that this is 50 as well. And that means that this is 60 as well. Using this information, I can see that there is a triangle happening here. And if I want to find how high the lights are, here's how I might do something like that. And you can pause the video and try and figure it out yourself if you'd like. Remember, we're trying to measure this distance. How high are the lights above the floor? So hopefully you recognize that, okay, well, if these three need to add up to 180, then if I subtract 60 from both sides, I'll see that this angle over here is about 70 degrees. And now, why are we measuring that when we're actually looking for the height? I'll tell you. In order to find the height, we need to create some sort of a triangle. And I can see a triangle happening here, but to do that, I need to know the length of this side to use it to find the height. Because right now in this triangle, the only thing I know is that this angle is 60 degrees. I know that this side is less than 5 meters, but is it 3.1? Is it 2.95? Is it 2.12? Who knows? The DJ is not exactly in the middle, otherwise both of these angles would be the same. So one way to solve this is to find out what x is first. And we can do that using sine law because we actually know that the track is 55 meters wide and this angle here is 70 degrees. So that's the reason I'm using sine law, because I have a pair. 5 over sine 70 should equal x over sine 50. And if I multiply both sides by 50, I'll see that the track is 4.07, or sorry, that this distance is 4.07 meters. Now it's time to find the actual height. Well, if that's 4.07 meters, and I can make a right triangle kind of just like this, I'm going to move that back. Well, then this is the angle, this is the hypotenuse, this is the adjacent. And so the sine theta, or is going to equals opposite of hypotenuse, is going to end up turning into sine 60 equals h over 4.07 with repeating decimal places. Now I want to get h all by itself, so I'll multiply both sides by 4.07, or I'll take my answer and multiply it by sine 60, and I end up getting about 3.52 my height. If you like this video, please like, rate, subscribe, and join our mailing list. And you can find this lesson as well as practice questions, solutions, handouts, and more on our storefront. Thanks and have a great day.